Welcome to the deep dive. Today we're going for a wild ride, I guess you could say, through the cosmos. Because you wanted to explore this idea, the possibility of black holes as portals to other universes.
Right.
We're diving into a 2010 scientific paper for this one and a recent Popular Mechanics article.
Okay.
And let me tell you, things are about to get seriously cosmic.
Yeah, what's so interesting about this is that it's not just, science fiction.
Right.
It comes from a real place in physics trying to figure out what happens at the heart of a black hole.
Okay, so before we get too far into the weeds here,
Yes.
how about like a really quick refresher on black holes for anyone listening who needs it?
Yeah, so imagine a place in space where gravity is so strong that absolutely nothing, not even light, can escape.
Yeah.
That's your black hole.
Huh.
And they form when these massive stars collapse at the end of their lives.
And it's this collapse, right, that leads to the singularity, which that's where things start getting really weird.
Yeah, you're telling me, imagine all the matter of a star crammed into an infinitely small point. And at that point, everything we know about physics, Einstein's relativity, it all breaks down.
So it's like the universe is divide by zero error message.
Exactly.
Yeah.
Our equations just can't handle it. And that's where this idea of torsion comes in, which is kind of a potential solution to this cosmic conundrum.
Okay, torsion. Break that down. What is torsion?
So think of it like this. Imagine wringing out a wet towel, right?
Okay.
That twisting force you're applying, that's similar to torsion.
Okay.
But instead of a towel, we're talking about the fabric of space-time itself. It's this twisting force that could actually counteract the pull of gravity inside the black hole.
Hold on. Are you saying torsion could prevent singularities from even forming?
That's the idea. Instead of collapsing into this infinitely dense point, the matter inside the black hole might actually get twisted and bounce back. Some physicists call this the Big Bounce, a potential alternative to the Big Bang.
Okay, now my mind is officially blown. So instead of a big bang, we might have had a big bounce, all thanks to this twisting force, torsion.
Right. It's a compelling theory, and this 2010 paper that we're looking at, it suggests that torsion could have been the driving force behind the rapid expansion of the universe, what we call inflation, in those first moments after the Big Bounce.
Okay. So we've been saying torsion this, torsion that.
Right.
What does it actually mean for physics if torsion is real?
It would mean that at the most fundamental level, physics is finite. There's a limit to how much the universe can be squeezed and compressed because of this repulsive force of torsion. This really challenges some long-held assumptions in physics, and it opens up a whole new way of thinking about gravity, about the nature of reality.
Finite physics. Okay, I need a minute to process that one. But wait, we haven't even gotten to the other universes part.
Right.
That's where the really mind-bending stuff starts.
Yeah. To get to how black holes might connect to other universes, we need to talk about something called an Einstein-Rosen bridge.
Okay, now that's a name I recognize.
Right.
Most people probably know this as a wormhole, though, right?
That's right. It's like a cosmic shortcut through space-time, connecting two distant points that would otherwise be impossibly far apart.
Okay, so wormholes, black holes. I'm starting to see the connection here. But we've never actually seen a wormhole, have we?
Yeah.
Are they even real?
Well, that's the million-dollar question, isn't it?
Mm-hmm.
They're purely theoretical at this point, but there's nothing in physics that says they can't exist.
So if they were real, how would they even form? And what would they look like?
Well, that's where things get really interesting. Some physicists believe that the immense gravity of a black hole could actually warp and distort space-time enough to create a wormhole.
So instead of a bottomless pit, a black hole might be more like a doorway.
Precisely.
And on the other side.
On the other side. It could be another universe or even a distant part of our own.
Whoa, okay. Yeah, that's where my brain starts to melt a little bit. But if we could travel through a wormhole, where would we end up? Would it be like some kind of mirror universe or a universe with totally different laws of physics?
It's really fun to think about because we just don't know. But the possibilities are pretty much endless, right?
Endless possibilities, you said it. But how do we go from these, like, mind-boggling theories to actual evidence? We can't just hop in a spaceship and fly into a black hole, can we?
Well, not with our current technology, that's for sure. But there are some indirect ways we might be able to learn about the true nature of black holes.
Okay, color me intrigued. What kind of clues are we talking about?
Well, for one thing, we can study the behavior of matter and energy around black holes.
Okay.
By observing how light bends and warps around these things, we can learn a lot about their properties.
So it's like trying to understand the shape of a shadow, but you can't ever actually see the object.
That's a great way to put it. And the more we learn about how black holes behave, the closer we get to unraveling their secrets.
And maybe, just maybe, those secrets will hold the key to unlocking the mysteries of other universes. But we'll have to save that for part 2.
You know, it's funny. For centuries, people thought of black holes as these, like, cosmic vacuum cleaners just sucking up everything in their path. But what if they're actually more like cosmic doorways?
Okay, I like where this is going.
Huh.
So last time, we left off talking about wormholes and the possibility of them connecting to other universes.
Right.
But how would that connection even work?
So remember how earlier we were talking about white holes? They're kind of like the flip side of a black hole.
Yeah.
Where instead of everything being pulled in, matter and energy are spewing out.
Okay, so black holes pulling things in, white holes pushing things out.
Yeah.
Are you suggesting that a wormhole could connect a black hole to a white hole? The cosmic tunnel.
You got it.
Like,
and that brings us to physicist Nikodem Poplawski and his theory.
okay.
He suggests that the immense pressure and, torsion inside a black hole could actually create a whole new space-time.
Hold on. Are you saying that our universe, the one we're in right now, could be inside a black hole?
Yeah, that's exactly what Poplawski proposes. He suggests that our Big Bang, the event that, created our universe, might have actually been the result of matter and energy erupting from a white hole into a new space-time, basically a new universe.
Okay.
And that white hole was connected to a black hole in some other parent universe.
Wow, that's a lot to take in.
Right.
So you're saying our universe is like a cosmic baby born from a black hole in another universe.
It's a wild concept, I know, but it actually fits with what we understand about physics, and it could explain some things about the early universe, especially that period of rapid expansion that we call inflation.
I follow you.
Yeah.
But if this is true, couldn't we theoretically travel through a black hole and then end up in this other parent universe, kind of like a cosmic homecoming?
Here's the thing, and it's a big one.
Okay.
Most physicists think that even if wormholes do exist, they would be incredibly unstable.
Oh, no.
Like, imagine trying to hold open a portal made of smoke.
Yeah, okay.
It wouldn't last very long. So even if we could find a wormhole, it might collapse before we could even get close.
Okay, so even if we could find one, getting through is a whole other issue.
Exactly. And even if we could somehow stabilize it and actually travel through it,
yeah,
the journey itself would be so dangerous, The gravitational forces would be unlike anything we can even imagine.
Okay, yeah. That's not on my bucket list then.
Yeah.
But okay, let's say, just for fun, that we could travel through a black hole.
Okay.
What would it even look like from the inside? I mean...
Well, this is where things get really interesting. So, as you approach a black hole, time would actually start to slow down for you, relative to someone who is watching from a safe distance, of course.
Wait, seriously? So time would move differently for us depending on how close we were to the black hole?
Absolutely. And then as you cross the event horizon, that point of no return, you'd encounter something called spaghettification.
Spaghettification. That sounds not great.
It's exactly what it sounds like. The gravitational pull would be so much stronger on your feet than your head.
Oh, no.
That you would basically get stretched out, like spaghetti.
Okay, yeah, that is definitely not on my bucket list. But, okay, what about the other side? What if we somehow survived the trip through the wormhole?
Right.
What would we see when we came out?
Well, that's the million-dollar question, isn't it?
I guess so.
Some theories say we'd end up in a completely different universe, maybe with its own laws of physics, maybe even different dimensions.
So it could be like stepping into another reality. Different laws of nature, different forces, maybe even different versions of ourselves.
The possibilities are truly mind-boggling. But for now, they're really just speculation.
Okay, so with all this talk of other universes and, physics that makes my head spin, is there any way to actually prove or disprove any of this? Or are we stuck with thought experiments and, wild guesses? So we're left with this idea, this possibility. Black holes as cosmic doorways may be leading to other universes.
Yeah.
But how do we go from speculation to actually figuring this out?
Well, we can't actually, see inside a black hole right now, at least not directly. But we can look for clues in the way they interact with, their surroundings.
Okay, I'm listening. What kind of clues?
So one really cool area is the study of gravitational waves. Remember, these are like ripples in space-time.
Yeah.
Caused by these huge cosmic events, like when two black holes collide.
Right, like throwing a rock into a pond and watching the ripples spread.
Exactly. And by analyzing the patterns of those waves, scientists can learn a lot about the objects that made them,
Yeah.
like their size, their mass, even their spin.
So it's like cosmic archaeology, in a way, using these waves to dig into the past and learn about these mysterious objects.
Yeah, and as we get better at detecting those waves and analyzing them, we might find things that our current theories can't quite explain.
Hmm.
Hints that something really unusual is happening inside black holes.
Okay, that makes sense. Gravitational waves are like a window, in a
Yep.
way, into this extreme part of the universe.
Mhm.
But is there anything else that could, help us prove or disprove these theories, the other universe's idea and all that?
There's another really interesting avenue, and it involves looking at the universe itself. I mean, the shape of
The
it.
shape of the universe. Now you're really blowing my mind.
Yeah.
How can the shape tell us anything about black holes or other realities?
It's about understanding how gravity works at the biggest scales,
Okay.
Imagine like a flat sheet of paper. Right now, imagine curving that sheet into a sphere.
Okay.
That's kind of what we're talking about with the shape of the universe. Is it flat? Is it curved? If so, how?
So you're saying the universe itself, like all of space, could be warped and twisted, just like the space-time around a black hole.
Exactly. And if our universe is curved in a specific way, it could be a sign that, well, we exist inside something else, like the inside of a black hole.
Okay, now my head is spinning. But how do you even begin to measure the shape of something as big as the universe?
It's tough, for sure. But scientists have some pretty amazing tools, actually.
Yeah.
One way is by studying something called the cosmic microwave background radiation. It's like this faint afterglow of the Big Bang.
Okay.
And by looking at patterns in that radiation, cosmologists can learn about the geometry of the universe at huge scales.
So we're looking for, like, imperfections in the afterglow of creation itself to see if the entire universe is curved, like the inside of a black hole.
Exactly. And the evidence is still, I'd say, up for debate, but some observations do suggest the universe might be slightly curved, which hints at, a much, much stranger reality than we might imagine.
It's incredible to think that we could be living inside a black hole, part of this, like, potentially infinite network of universes.
It's an amazing thought, isn't it? And it really highlights how much we still don't know about the universe and our place in it.
Absolutely. So I guess we've gone from the depths of black holes to the edge of, well, what we even understand about the cosmos.
We really have. We've gone through some mind-bending theories, talked about stuff that seems impossible in our daily lives, and just, come face to face with the biggest mysteries out there.
And even if we don't have all the answers, it's asking those questions that really makes us human, right?
I think so.
The universe is vast. It's amazing. There's so much out there we haven't even imagined. And it's all waiting for us to explore it.
And who knows, maybe someday we will unlock the secrets of black holes. Maybe we'll find out if they really are these doorways to other universes.
Until then, we keep exploring, keep asking those questions, and keep our minds open to, well, the infinite wonders of the cosmos. Thanks for joining us on this deep dive.